So today we're going to start with the first number-based program, and I've selected a number which you're going to check whether it's a palindrome or not. So we can create a class called palindrome, and then we press OK button. A class has been created. So we just open the editor there. Then we can highlight this and remove the outline program. And we can start with a question here. So what is the question? Write a program to input a number and check if the number is a palindrome number or not. Okay. Now, what is a palindrome number? A palindrome number is a number whose reverse form of the number is same. So let us take an example. You can say example here. If I say a number, say 1331, and if we reverse that number, and if we reverse the number, we will get the same value. So that is the reverse of 1331 is also 1331. So it proves that the number is a palindrome. Now how we are going to do this program? First of all, since we are going to input the number from the terminal window, we are going to import a package called java.util. Now this package contains many classes, but our main utility class is the scanner class. Now this class will contain functions which will help us to input values from the terminal window. So as the class name, we have given as palindrome. Initially, we have to use the same name. And then we get inside the body of the class. We start with the function name. So we can have static void main as a function name. This much will be enough. And then the next thing what we have to do is we are going to create an object of the scanner class. So that means this scanner class will create an object which I have given as a name called SC. You can give any other name. New scanner. We have a scanner constructor, and then we have system.in, which is help us to enter value from the terminal window. So here SC is actually just a variable name. Over here, since the class is creating the variable, so therefore the SC is actually called an object variable. Now this object variable, this variable is actually, we are using it to connect with the keyboard because our main input is from the keyboard. So SC is a variable which is representing the keyboard, you can say that. Okay, now we can declare a variable. First variable we can declare is n, because this variable n will take up a number from us from the terminal window. So we can have a print statement which will send up a prompt message on the screen to suggest that we are going to enter a number. So we can give us prompt here, enter a number, because prompt is very important, because without prompt the computer is not going to take you to the terminal window. So system.out.println, you're giving a message, enter a number, and now we are going to enter a number to this variable called sc.nextInt. So this is the function of the scanner class, that is nextInt is a function of the scanner class. Since we are going to enter integer value, so therefore we have chosen a function, a built-in function under the scanner class called nextInt. So therefore nextInt is a function, I repeat, of the scanner class through the object called sc. So this object has been created by the scanner class. So you can see this line, object creation. So with the help of this variable sc, we are using the function called nextInt, and this will help us to accept the value from the terminal to the variable n. So n is going to receive the input value through the nextInt with the help of this sc object, and n will have the number. So once the number has been given to n, for example, let us assume, well, side by side we're going to take a example value there also. So let us assume that I have given the value of n to be 1331. I can give any number. So just for understanding, I'm using the variable n as 1331. So after I input it, the next thing comes is we are going to extract the digit one by one from that number. Now since we do not know the size of the number which you can input can be a 2-digit number, or can be 3-digit, or can be 4, or can be 5, anything. So it's important here that we extract the digit from the units place of the number, that is from the ones place, that is from here, ones place, followed by tens place, then 100 place, and then 1000 place, like that. We are going to extract the digit right from the end of the number, that is from the ones place, that is units place, then tens place, then hundreds place, then thousands place. Now how we are going to do that? Definitely we are going to use a loop to extract the digits. Now we can have, there are 3 kinds of loop in programming, which is for loop, while loop, and do while loop. So I can choose using for loop over here, or I can use a while loop also. So I'll show you in both the ways, don't worry. So if I use for loop, I can define a variable m which will take a copy from n. That means we cannot lose the original value of the variable. No? We cannot do that. So we'll take another variable m which is going to take the copy from m. So m will also become 1331. And we are going to return the value variable n. Okay, the value of the variable n, so that we can compare in the end whether the original number is same as a reverse number or not. And then next there will be a condition. We'll put a condition for the loop, because till the time the value of m is more than 0, that means if there are digits still there in that number m, the loop will continue, because we need to extract all the digits from the number, and the loop will continue. And further we can give an updation here, m is equal to m/10. Now why this m is equal to m/10? That I'll explain. So what we do, we enter inside the body of the for loop. So as I said, m takes a copy from n, so m will also become 1331. Okay, now what happens now? We have a condition. Is m greater than 0? Yes, it is. Yes, it is greater than 0. The condition is true. So we'll fall inside the body of the loop, and we will try to now extract the digit from 1331. So as I said, we are going to extract the digit from the last, that is from the ones place. So what we do, we use a variable d, and we'll say to computer to extract the last digit from m by using the formula d is equal to m modulus 10. Now modulus stands for remainder over here. So what is happening over here? What is the value of m? 1331. The next is modulus, that is remainder, 10. So that means when we are dividing any number with 10, the remainder is always the last digit, that is 1. So d will now hold 1. That means the first digit from the ones place of the number 1331, we have extracted 1. Okay, once that has been extracted, so now we are going to declare the variable d also in the beginning. Otherwise, it's going to continue to show the error. So now next is we are going to form a new number out of m. So we'll take a variable s, which is going to create a new number. That is the reverse of 1331. So the formula is s is equal to s into 10 plus d. So what happens over here? Since we have declared a new variable s, we'll declare s to be 0 in the top. We cannot have, we should initialize the value of the variable which is continuously being updated as 0 in the initial, that is in the beginning, during the time place where we have declared those variables. So the formula s is equal to s into 10 means we are trying to form a new number by continuously placing the digits in the end of the number. So s is equal to s into 10. So initially the value of s is 0 into 10 plus the digit extracted is 1. So when we calculate, we have 0 plus 1, which is 1. So now s has taken the first digit 1 from m. Okay, so next is we go back again to this formula m is equal to m slash 10. Watch this very carefully. M is equal to m slash 10. So m is equal to m slash 10 means we are trying to divide the value of 1331 with 10. Since it's an integer division, the answer will be 133.1 in originally, because when we divide a number with 10, the decimal point shifts to the one place of decimal from the end of the number. So, but since it's an integer division, the last digit will be truncated, 0.1 will go off, and m will now have 133. Now we face a condition here, m is greater than 0. 133 is greater than 0. Yes, it is. Yes, yes. So that means the loop still continues, goes inside the body of the for loop. D is equal to this time 133 modulus 10, which is 3. That is the last digit of 133 is 3. So now we fall back to the next statement, s is equal to s into 10 plus d. So the formula now is, we have now the last value of s to be 1. So 1 into 10 plus 3, we get 10 plus 3 is equal to 13. So now the reverse of 31 is 13. Fine, good now. So go back again to the for loop. We come to this m is equal to m slash 10. This time the value of m was 133. So 133 divided by 10 will become 113.3. So the last digit will be truncated. So I have 13 now. Now 13 is greater than 0. Yes, it is. Still digit has to be extracted. So 13 is greater than 0. Condition true. Comes down. D is equal to m modulus 10. 13 modulus 10 will be 3 again. Comes down. Last time the value of s was 13. Now 13 into 10 plus 3. So it becomes 133. So reverse of 331 is 133. Okay, so come back again to the for loop. Come to this statement, m is equal to m slash 10. So here, this time the value of s, m was 13. 13 divided by 10 is 1 because 3 is gone. Now is 1 greater than 0? Yes, it is greater than 0. That means the loop is still going to be continued. Now comes back to d is equal to m modulus 10. That is 1 modulus 10, and 1 modulus 10 is always 1. When the numerator is smaller than the denominator, during the time of remainder, during the time of modulus, the answer is always the numerator. So 1. So s is equal to s into 10, 133 into 10 into 10 plus 1 will become 1331. So now you have a new number. This time it is 1331. Goes back again to m is equal to m slash 10, and this time it was 1. 1 divided by 10 will be 0. Is 0 greater than 0? Condition is false. The condition is false. We can say no. So the loop exists now. The loop is going to exit. Computer will come back to the next statement outside the body of for, because all the digits have been extracted. The condition m is greater than 0 is become false now. So comes over here, the final statement will be if condition. So that means the value of s, which has been created, a new number has been formed, is going to check with the original number which you have input, that is n. So that means this time if is going to check with 131331 is equal to 1331. Yes, it is. Yes. So condition becomes true in this case. So the computer is going to print system.out.println. We should give a very nice prompt. N plus is a palindrome number. Okay, that's fine. Else system dot out dot println n is not a palindrome number. That's it. So this will be the complete program. So let us understand by running the program here. We compile it. There is no syntax error. All the variables are intact. All the conditions are okay. And okay, I can put it very nicely here with good indentation. So we come to close it. We find that it's been compiled perfectly. We can click on the void main function. So click on it. You'll have the terminal window asking for a number. I can give a number, say 4554. I can give this. Okay, and reverse of 4554 is also 45554. So when we enter it, the computer gives the answer. That is a palindrome number. Okay, so you have understood this. We can also give another kind of number which is not palindrome. Let's say we give 1 2 3 4 5, and the reverse of 1 2 3 4 5 is 5 4 3 2 1. Of course it is not palindrome, so it says not a palindrome number. That's it. So we have these two answers here. Now I can do a slight change over here. So those who feel that while loop can be a perfect way of doing this program, no problem with that. What we do is simply change the text over here from for to while, and while only takes in the condition, not the initial and not the initial and not the condition and not the updation. So what we do here is, since m is equal to n is going to work only for the first time, one time only, we can initialize it over here and remove it from here. Okay, we have removed it. And then we can remove this updation also, because while does not like any other statement except the condition over here. So we can cut it off, but we have to place it over here. We have to. Okay, we are placing it over here. You can place it anywhere after d is equal to m modulus 10. After this, we can place it anywhere. So we can remove the semicolon because that's not a part of the syntax of while. So now what will happen is, we have done the same thing. The only difference is that we are giving a condition loop. So initial has gone up here, updation has gone down over here, the condition remains intact over here. The only thing is that the statement inside the for has been split into three parts over here separately using while loop. So again, comes to the same thing. We compile the program. There's no problem with that, and the computer is going to run the program perfectly. The only difference is we have changed the style of the loop. So if I give a number, say 4004, so of course the reverse of 4004 is also 4004, so says it's a palindrome number. So that's it for today. We have discussed about a type of number which is a very popular number called palindrome number. In the next class, we are going to come to another kind of popular number. Thank you for today.